All right, so this week we are doing quite a few things involving exponents. We're going to be learning all these different rules of exponents. And I wanted to revisit evaluating exponential expressions because this will kind of help you understand some of the rules of exponents that you're going to be learning and working with. So we haven't really done much with exponents since week 1 when we had order of operations. So an exponent is basically repeated multiplication. So if you have some number b and then it has an exponent n, you're multiplying b by itself n times. So 2 to the 4th power, I write that in here. So like 2 to the 4th would mean that you have 4 2's multiplied together. So this understanding of what exponential notation means is going to help you understand the rules for exponents and why the rules are what they are. So just some tips. This is basically reviewing things that we did with the order of operations, as you want to make sure you know the difference between the negative that's outside parentheses and when it's inside parentheses and when they're evaluated, because it's very, very different. So like negative 2 to the 4th versus negative 2 to the 4th. Those don't give you the same answer. The first one, if there's no parentheses, means you're doing 2 to the 4th and then you do the negative. So that negative is not part of your exponent. However, if it's in parentheses like it is on the right, then it is part of your exponent. Because now it's in parentheses, so now you have the whole number negative 2 to the 4th power. So it's really important to understand the difference between those two. Now, if we focus on just the second form, the exponent will tell you whether your answer is going to be positive or negative. The first form, you always get a negative answer because you do your exponent and then you have a negative in front. The second one, it depends on if your exponent is positive or negative. Or not positive or negative, I mean if it's even or odd. So if your exponent is even, that means any negatives cancel out, so you're going to get a positive answer out. So negative 2 to the 4th is going to give me a positive answer out. 2 to the 4th is 16, so I'm going to get a positive 16. But if I have negative 2 to an odd exponent like 3, I'm going to get a negative answer, so that would be a negative 8. Because in that case, if you have 3 negative signs, 2 of them cancel out, but the third one doesn't, and so you're still left with a negative there. So understanding how exponents work in regards to positive and negative numbers can make your life a lot easier when you're going to be evaluating exponential expressions and when you're simplifying things with exponents. So from here, I just have lots of different examples of showing you all of these different ways that we can work with exponents and how to evaluate them. And then we'll start moving into the types of things that you'd see if you are evaluating or simplifying an exponential expression. And you'll see that the rules we're going to be using are going to be the same rules when you start using variables. But I'm just focusing on using numbers for now, basically. So we have negative 3 to the 4th power. That negative is not part of the exponent because it's not in parentheses. This is the same thing as having a negative, but then doing 3 to the 4th power. So you're going to have 4 3's multiplied together. So your answer is going to be negative. So you're welcome to use your calculator and do 3 to the 4th, which is 81, and then we have a negative answer. So this gives us a negative 81. Now on the right, the negative is in parentheses. So this is equivalent to a -3 times a -3 times a -3 times a -3. So see the difference. On the left, it was 3 to the 4th power, and then we had a negative there. But on the right, it's -3 to the 4th power. So you're multiplying -3 4 times. And so those two negative numbers are going to give you a positive. These two are going to give you a positive. And so your answer is going to end up being positive, because this gives us a 9 and this gives us a 9. And then 9 times 9, we get a positive 81. So there's a big difference between these two on whether your answer is going to be negative or positive. And you can see here on the example on the right, we had an even exponent, so that meant we're getting a positive answer out. Now, bottom left here, I've got -5 to the 3. So that negative is not in parentheses, it's not included. So this is 5 to the 3rd power, and then we have that negative in front. So 5 to the 3rd power is 125 when you do that on your calculator. And then we have a negative. So this is going to give us a -125, sorry. Now on the right, we have a -5 to the 3rd. So that negative is included. We're multiplying -5 3 times. Those first two are going to give us a positive number out, because a negative times a negative is a positive. We're going to get a positive 25. But then we have another negative we're multiplying it by. And so 25 times -5 is -125. So in this case, these gave us the same answer. The difference is whether your exponent is positive or negative on whether your answer is going to be the same thing when you have a negative involved. Now also notice that the -5, that whole thing in parentheses to the 3rd power, that was an odd exponent. And as I said, the odd exponents will give you a negative answer out. So you want to be very careful to understand what these exponents mean, because that helps you determine what the sign of your answer is going to be. And it's important to make sure you enter it in your calculator correctly as well, because parentheses make a difference, especially when you have an even exponent. So if you don't have parentheses where you're supposed to have parentheses, your calculator is going to give you the incorrect answer. Your calculator is only as smart as what you enter in, and if you enter it wrong, your calculator is going to do what you told it to do. But if what you told it to do is wrong, then it's going to be incorrect. Are there any questions so far? Okay. Now I'm throwing in some different negatives here, going in different places. Where the negatives are, you know, it matters. So let's look at the first one on the left here. We have a negative and then -3 to the 4th power. So negatives are not, if you have an exponent, you cannot distribute negatives. So you can't say a negative and a negative cancels out here because you have an exponent. You always have to do the exponent first. So we have a negative, and then I have -3 to the 4th power. So that's -3 times -3 times -3 times -3. So if you count how many negative signs here, we actually have 5 negative signs. And the number of negative signs, basically, if it's an even or odd number, determine if your answer is going to be even or odd. Now we know that the parentheses -3 to the 4th gives us a positive 81 because we just saw that on this previous slide. But now we have a negative in front, so this is going to give us a -81. So you need to remember the order of operations, PEMDAS, where you have to take care of the exponent before you multiply. So we have to do the exponent, -3 to the 4th, before you multiply by the negative in front. If you do that out of order, your answer is going to be incorrect. On the right here, we have a -3 to the 4th. This is actually the same thing as if you had it without the parentheses. That negative is still not included because it's not in parentheses with the 4th exponent. So 3 to the 4th is 81. This is also going to give us a -81 here. And we saw this on the previous slide, the first example here. It's just another way of writing it. Now, bottom left, I've got a negative and then parentheses, -5 to the 3rd. So again, we need to do the exponent first. So we have a negative, and then we have -5 to the 3rd power, which is basically -5 multiplied by itself 3 times. So we've done that. That was this example bottom right here, -5 to the 3rd power. That gave us -125. So we have a negative and then a -125. And now when you multiply those, a negative times a negative, because with two negatives, they cancel out. This gives us a positive 125. Now we're not distributing that negative before we do the exponent. We're doing the exponent first, and then you're dealing with the negative. And then the one on the right, again, if you don't have that negative in parentheses, that negative is not included. And we can also write this as -5 to the 3rd without the parentheses around the 5. It means the same thing. And we actually saw this again on this previous slide that gave us -125. So it's really important to figure out all of these negatives and keep track of them when you have exponents, because as we start doing more things with exponents, if you have your negative sign wrong, it's going to mess up everything that you're doing going forward. Because we're going to start doing multiplying of things with exponents. We're going to be dividing things with exponents. And so you want to make sure you have your signs correct before you go forward. Are there any questions? Okay. So let's look at how these things work when we have fractions. And this is where you're going to start seeing a connection to some of the rules of exponents that you'll start learning. Because some of our rules of exponents apply to things that are fractions. So we have on the top left 1/5 squared. So this is just 1/5 times 1/5. So when we multiply fractions together, you're multiplying the tops together and the bottoms together. So you have 1 times 1, which is 1, and 5 times 5, which is 25. So this gives us 1/25. Now on the top right here, I have 1/5 squared. So the 5 squared is 5 times 5. And so we get 1/5 times 5, and we also get 1/25. And this brings us to one of our rules of exponents, that these are basically the same thing. So if I have 1 to the 5th squared, we have a rule for exponents that basically says you square the top and you square the bottom. So the top and the bottom get that exponent. So that would be 1 squared over 5 squared. Now 1 squared is 1, so that's why it's equivalent to what we saw on the right, because 1 squared is equal to 1, and then 5 squared is equal to 25. So that's one of the rules of exponents. And you can see that it comes out to the same thing because we have 1 on the top. And if you look at what we have here on the first example, if I rewrote what I had, 1/5 times 1/5, that would be, we basically did 1 times 1 over 5 times 5. So that's 1 squared over 5 squared. So these are equivalent. So that's one of our rules of exponents, is that if you have a fraction and there's an exponent on the outside, you can basically attach that exponent to everything on the inside. So bottom left here, I have 1/2 to the 3rd power. So we'll see how this works. So 1/2 to the 3rd power is same as 1/2 times 1/2 times 1/2. So if I rewrote this, that would be 1 to the 3rd power, because it's 1 times 1 times 1. And then in the denominator, you're multiplying 2 times 2 times 2, that's 2 to the 3rd. So the same rule applies here. That exponent of 3 gets attached to the top and to the bottom. And that makes it a little bit easier, because instead of multiplying your fraction out and writing it out 1/2 times 1/2 times 1/2, instead you can work with the whole numbers and do 1 to the 3rd power and 2 to the 3rd power on your calculator. So it makes it easier to get the answer. So in this case, this will give us 1/8. And this is the same answer we're going to get with 1/2 to the 3rd, because 1 is the same as 1 cubed. So we also get 1/8. So the way that we write this rule, I can actually get my pen to write, is that we'll usually indicate it with like a over b to some exponent n is the same as a to the n over b to the n. So that outside exponent can be attached to everything inside when you have a fraction. Are there any questions? Okay. So now we're going to do a little bit of evaluating with variables, but we're still going to be working with exponents here. It's just replacing the variables with some numbers, because we're going to just work more with some of these other rules that are going on. So a is equal to -4 and b is equal to 5. So I have -4b squared. So this is basically practicing some order of operations. I replace b with the number it's equal to, which is 5. And every time you plug in a number, it's good practice to put parentheses around it, especially if the number you're plugging in is negative. That way you don't make any mistakes with your signs. So evaluate basically means find the answer. As we've been doing all of these that evaluate, it's basically simply like do the order of operations, do the math, get me your single answer. That's what evaluate means. So we're doing the same thing here. Exponent comes before multiplication. So I need to do 5 squared first, and that's 25. So I have a negative 4 times 25. And when you multiply, that gives you negative 100. Now on the right, notice that this is slightly different because we have parentheses around the negative 4b, and then we have our exponent. So when we perform this, it's actually going to be in a slightly different order, but we still need to plug things in. So I have my negative 4, and then I'm multiplying it by b, so that's a 5 right there. And then I have my exponent. So order of operations, we need to do inside the parentheses first before we get to the exponent, because it's parentheses before exponents. So I need to do negative 4 times 5 first, which is negative 20. And then I do my exponent. And so negative 20 squared, that's negative 20 times negative 20. That's going to give us a positive 400. So you can see this, the difference here of simply having parentheses. It gave us two very different answers. We plugged in the same number for B. It looks almost identical, but those parentheses makes a huge difference because it changes the order of operations that you're doing here. Bottom row, let's look at the 3a. That whole thing is squared. So we need to do the 3 times a first. So we need to first plug in for a. So a is negative 4. So I'm putting that in parentheses so it doesn't look like it's going to be subtracted. And then that's squared. So because it's 3 times a, so you need to make sure you indicate that as parentheses or as multiplication using parentheses, because otherwise without the parentheses it looks like 3 minus 4, and that's something completely different. So with 3 times a. Order of operations here says that we need to do inside the big set of parentheses before we do the exponent. So I need to do 3 times negative 4 first. That gives me negative 12. And then we square. And this is a negative 12 times a negative 12. So that's going to give us a positive 144. Now on the right, I have a negative 10 times a times b squared. So I have negative 10. I'm multiplied by a, and I'm going to use parentheses to show that multiplication, and a is negative 4. Then I'm multiplied by b squared. So that's going to be b, which is 5, and then the exponent. So order of operations, we have to do the exponent first. So I need to do 5 squared first. So that's 25. And then I still have my negative 10 and my negative 4. And these are basically all multiplied together. So when everything is multiplied here, you're going to work from left to right. So I need to do the negative 10 times negative 4 first, which gives me a positive 40. And then I'm multiplying by 25. So when I do 40 times 25 on my calculator, I get 1,000. Are there any questions so far? Okay, same values for a and b here. We're going to change it up, change up some of where the exponents are and everything like that, but same values for a and b. So I have negative 6, and then a cubed. So a is negative 4. Then I need to have my exponent of 3, and then I'm multiplying by 5. So order of operations, we need to do the exponent first. We have negative 4 to the 3rd power. So when you put that in your calculator, you have to have the parentheses around the -4. So this will give me a negative out because it's an odd exponent, and I get a -64. So we have -6 times -64 times 5. So now order of operations says we go from left to right. And because it's all multiplication, I can put this in my calculator all at the same time. So I can put in a -6 times -64 times 5. And my calculator will follow the order of operations there. When it's all multiplication, it goes left to right. So we're going to get a positive answer out because we have two negative signs. Those will cancel, which gives us a positive. We get a positive 1,920. Now on the right, this is very similar to what we saw in the previous slide, but the square was on the B. Now the square is on the A. So where that exponent is does matter. So we have a -10, then A squared. So A is -4, and then that has the exponent of 2, and then B is 5. So we need to square the -4 first. That's -4 times -4, so that's going to be a positive 16. And we're going to get a negative answer out here because we have one negative sign. So I'm going to, again, this is all multiplication, so I can do it all at once on my calculator. -10 times 16 times 5. Get -800. Bottom left, -a squared b. So I've got a negative sign. Then I have a squared. So a is -4. Then I square it. And then b is 5. So we have this negative and then the parentheses -4 squared stuff that we were seeing before. Remember, exponent comes first. So I need to square the -4 first. And that gives me a positive 16. So I have a negative, then I get 16, and then I get 5. So we have one negative sign. We're going to get a negative answer. And this is basically the same thing as -16 times 5. So we get -80. On the right, 3a squared. So I have my 3. I'm going to plug in -4 for the a, and then we square it. So we have to do our exponent first. -4 squared is 16. So this gives us 3 times 16, which is 48. So this is practicing with evaluating. And evaluating when you have variables means you need to plug in numbers for your variables, and then you're following the order of operations, and you're going to get a single number as your answer. Are there any questions? Okay. So now we're going to move into some other types of problems with exponents. Now notice our directions here have changed. These don't say evaluate anymore. Now it says simplify. So simplify basically means you want to rewrite it as simple as possible, but you're not actually doing the order of operations here. So what this is telling us is that we don't actually want to calculate the number. We're going to leave it in exponent form, but we're going to try to simplify it as much as possible to get smaller exponents, or try to make it smaller. So do not evaluate. We're not doing the order of operations here. We're not multiplying, dividing, doing all that kind of stuff. We are just using what we know about exponents to rewrite these things in a simpler way. So we have top left 4 to the 5th times 4 to the 9th. So in order to simplify this, we want to look at what does this mean as far as exponents go. So 4 to the 5th means that we have 5 4s multiplied together. And then 4 to the 9th means we have 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you may be thinking, well, this certainly doesn't look simpler, but when you write this out, you see that instead of writing this as two separate things with exponents, we can combine this as a single exponent. We have 5 4s and then 9 more. 5 plus 9 is 14. So we have 14 total 4s here. So we can rewrite this as 4 to the 14 instead of 4 to the 5th and 4 to the 9th. So that's what it means by simplifying. Instead of having these two things with exponents that we're multiplying, we're combining them into a single exponent, a single exponential expression here. So it is simpler. Now the exponent's larger, but it is simpler. Now the same thing that we did here with the 4s, we can do with the 6 to the 7th and 6 to the 5th. Now, if you notice what we did is that we basically ended up adding the exponents together, because when you wrote it all out, you're just counting how many you have written out, so you can add those two groups together to get the total number of 4s. So this is one of our rules of exponents. And this will be written like a to the n times a to the m. So the same thing, the same base, same thing under the exponent. Your rule says that you can add those exponents together. And that's exactly what we did on the left. We wrote it all out, and then you see that we added the 5 exponents to the 9, 5 4s to the 9 4s. They gave us 14 4s together. So using that rule, this 6 to the 7th times 6 to the 5th is 6 to the 7 plus 5, which gives us 6 to the 12. So instead of having to write out all of those 6s multiplied together, we did that in the first time. We see a pattern. We can use that pattern, that rule, to do the math and simplify this without having to write it all out. You just add those exponents together. So bottom left, we have 2/3 to the 3rd and then another 2/3. So we can rewrite this so that we can use this rule. We have 2/3 to the 3rd. And then if you have a 2/3 without an exponent, you can always write an exponent. If you have anything without an exponent, you can give it an exponent of 1. So we can use the same rule here where you add the exponents. And this is equal to 2/3 to the 4th. We're basically adding an extra 2/3 multiplied to the existing 3. So now we have 4 of them multiplied together. Now, bottom right here, this is a different situation because we don't have something multiplied together. Now we're doing division. We have a fraction. So let's expand out our exponents and see what happens. So on the top, I have 8 to the 8. So that's 8 8s multiplied together. 1, 2, 3, 4, 5, 6, 7, 8. on the bottom of the fraction of 8 to the third. So there's 3 of them multiplied together. 8 times 8 times 8. Now, if we go back to when we were learning about fractions in week 1, we were doing things like this where you can cancel things out by crossing it out of the top and the bottom. So I can remove an 8 from the top and the bottom and cancel those out. And I can keep doing that until there's nothing left for me to cancel out. So when I do that, I'm left with only 5 8s on top, nothing on the bottom. So this is equal to 8 to the 5th, because we have 5 8s left over. And this gives us another rule, because if you notice, on top we have 8, on the bottom we have 3. We basically removed 3 8s from the existing 8 8s, so we're subtracting 3. So we could subtract the exponents to get our answer here, top minus bottom. So this rule is usually written if you have a to the m over a to the n. You can simplify it by doing m minus n. You can subtract your exponents top minus bottom. Because when you write out what the exponents mean, things cancel. You're basically removing those bottom 3. You can cancel it out with the top. So 8 minus 3, that gave us 5 there for that example. Are there any questions? All right, so to simplify these kinds of things, we're going to use these 2 rules together. So again, I'm going to rewrite our rules. A to the m times a to the n, a to the m plus n, and then a to the m over a to the n is a to the m minus n. So based off of these patterns and these rules of exponents, we're going to use these shortcuts here where we're going to be adding exponents and subtracting exponents in order to simplify these without having to write them out or even do it on your calculator. It's a lot easier to work with these in exponent form rather than finding out the numbers on your calculator. Like the bottom left here, I don't want to do 10 to the 20th power on my calculator. I don't even know if my calculator can give me that number, and then have to divide it by these things in the bottom. Like it's too much work. And we don't need to do that much work when we just have our rules of exponents. So top left here, we have 7 squared, or 7 to the 6th over 7. So the general rule is that you need to do your multiplication pieces first before you do the fraction pieces. So we need to combine the top parts of that fraction first, and then take care of the denominator. So for the top, we're adding those exponents together. So that's going to be 2 plus 6 that we're going to get on top. Now on the bottom, I just have a 7 and there's no exponent, so I'm going to give it a 1. Because that will allow us to work with these rules. Now I kind of don't really have any room here, so I'm going to move to the right. So I get 8 as my exponent on the top because 2 plus 6 is 8. And then I have 7 over 1. And now we're going to use the rule with the fractions where you subtract the exponents top minus bottom. So that's 7, and then it's going to be 8 minus 1, which gives us 7 to the 7. Now, I usually do the addition and the subtraction in my head, but there are things when you get into more complicated algebra where you start having negative exponents, and then because of those negatives, people start messing up. Because subtracting a negative, once you start throwing in negatives, there tend to be errors. So I recommend writing down your steps here, writing down what we're adding together, writing down what we're subtracting. That helps you see the rule in action. and it helps you check whether you're going to be making any mistakes or not, or if you made a mistake, try to help you find it. So top right, we've got 5 to the third over 5 to the 8 over 5. Now I don't have as much room here because I should have moved my left side over. So I'm going to just add and not write that step. 3 plus 8 is 11. So I have 5 to the 11, and then if there's something without an exponent, I'm just going to give it a 1. And then I'm going to subtract my exponents, top minus bottom. 10 or 11 minus 1 is 10. So we're going to get 5 to the 10th here. And I don't know what 5 to the 10th is on my calculator. I don't really care to want to have to figure that out. It's a lot easier leaving it as an exponent. Bottom left, now we have 10 to the 20, and then on the denominator, we have two things multiplied together. So now we're going to have to simplify the denominator first before we deal with the whole fraction. So I'm going to move over this time and be smart about it. 10 to the 20. In the denominator, I need to add my exponents, 3 plus 8. So this gives me 10 to the 20 over 10 to the 11. Once you've simplified it so that you've got something with an exponent over something with an exponent, that's when we can use our rule to subtract. So it's always top minus bottom. 20 minus 11, and that gives us 10 to the 9. So same thing on the right, we have 3 to the 15 over 3 squared, 3 to the 10th. So 3 to the 15, and then I add the 2 plus 10 for my exponents in the denominator. So I have 3 to the 15 over 3 to the 12th. Now we're going to use the rule where we subtract. So it's going to be 15 minus 12. So it's the top exponent minus the bottom one. And that gives us 3 to the third. And these all say simplify. So you're going to leave it in its exponent form because that is simpler than actually finding out whatever that number is on your calculator. A 3 to the third is 27. That's not too bad. But for most of these with high exponents, it's going to be a big number. And it's just easier to keep it in its exponent form. So when it says simplify, you're going to keep it as an exponent. Generally, there are some where if you're mixing numbers and variables, you will evaluate the number and then keep the variable in its exponent form. So you're kind of doing both. But in these cases, we're just rewriting them as exponents because we're practicing these rules. So are there any questions? Okay, so this is basically everything I planned to go through. I wanted to basically take what we did in week 1, where we're working with order of operations, review that, and then use that to lead us into these new rules of exponents that you're going to be learning. So you can see the connection that we're following the same process. We're using the same definition of an exponent, but we're using it to write things in a different way. That kind of saves us some time, saves us some work. So there are other rules that I haven't covered here. There are rules for if you have something with an exponent and then another exponent. There's rules of doing that when it's also a fraction. There's other rules, but these are the most basic ones. And if you follow these rules, then you can figure out the other rules as well, just by simply rewriting them.